All right, guys, so what we're starting today is chapter 3. We are starting our chapter over parallel and perpendicular lines. Now, for those of you, again, a good number of you don't have everything turned in from chapter 2. I will give you till Monday to turn it in. After Monday, it will be zeros, and then that's going to be it. So some of y'all need to get some of the assignments turned in. Yeah, really, it was supposed to be yesterday.
What was the thing about the academic?
Because you need to check in with me before the end of the day. Sophomores through seniors. Well, we'll talk about it here in a minute. Now, here, so parallel lines, skew lines, and parallel planes. Now, y'all looked up the vocabs for these yesterday, so you've already looked at these terms. Now, parallel lines are going to be two lines that do not intersect and are coplanar. So for two lines to be parallel, they have to be in the same plane. They have to be contained in the same plane for them to be parallel. Skew lines do not intersect and are not coplanar. So if two lines do not intersect and are not in the same plane, they're considered to be skew. If two lines are parallel and in the same plane, they're parallel. So they're parallel if they're in the same plane and do not cross. They're skew if they do not cross and are not in the same plane. And then parallel planes are two planes that do not cross. Questions on this so far? So if we look at this first example here, think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? So our first one, lines parallel to CD and containing point A. So they already drew CD for us here and contain point A. So for it to be parallel, it has to be in the same plane, yes? So there's two lines that are actually parallel to CD. One of them is EF and the other is AB. But EF is not going to be the correct answer because they want what? They want a line containing what? A. So the only line that's parallel and contains A is AB. This line here would be the only line that's parallel to CD and contains point A. Questions on this here? Let's look at the next part. Lines skew to CD and contain point A. So for it to be skew, it can't intersect CD and it cannot be in the same plane. AG, yes. This one here, we can actually have another one because AG would work. What else would work? HA or AH? It has to contain point A. So either one of those work. Because AH is not contained in the plane and AG is not contained in the plane. And neither one of them intersect our original line. Any other questions on this here? Ready for the next one? So we want a line perpendicular to CD and contains point A. So perpendicular are two lines that intersect at a right angle, yes? So what line would be perpendicular to CD and contain point A? AD. Because AD does intersect line CD. And if we look at point D, their point of intersection, we do have that right angle marker. So they do intersect at a right angle, which means that they are perpendicular to each other. Any other questions on this so far? The next part, planes parallel to EFG and contain point A. We don't need that anymore. So EFG. So we're talking about this plane down here. We want one that's parallel to it and contains point A. So plane ACB. I mean, we could name it differently. What else could we have named it? DCA, ACD, ABC, any of those four letters. work. Mm-hmm. Yeah. No, just any of those three. You just need one of those three out of those 4 points. Any other questions on this here? We like this so far? Okay. Number one, look at the diagram in example on this one here. Name lines through point F that appear to be skew to EH. So skew to EH. So EH is here and contain point F. So what is skew? So they do not intersect and are not contained in the same plane. FC. And it has to contain point F. FG does not intersect EH, but is EH and FG in the same plane. So they're not coplanar, or they're not skew. They'd be parallel, but they were not skew. Skew, they cannot be in the same plane. If there was a line connecting the two, yes. Yeah, in the diagram. So look at the diagram, and which one appears to be skew. So they didn't want us connecting anything that wasn't already connected. Questions on this here? Okay. So we can look at a few more of these here. Think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? So lines parallel to GH and contain point H, or point F, sorry. So FE, yes, would be parallel because it's in the same plane and they do not intersect. What would be the next one? So skew to GH and containing point F. So FH would not work. Up and down. FB. FG would intersect it. FB. Bless you. So FB would be skew. So with this here, so lines perpendicular to GH containing F, so one of the points is going to be F. This time it would be FG, because we're going to say that they do intersect at right angles.
But how can you say that?
Yeah. Appear to fit the description. But for most of them, especially on the test, I will include the right angles for this here. Well, that was what we would assume, yes.
But he also taught us that we can't.
Yeah, we can't normally assume it. For this here, I mean, we'll have to assume it because they didn't specify as otherwise. Appear to fit the description. Yeah. And last one, planes parallel to GHD and contain F. So that would be plane. Well, we're going to need F. Mm-hmm. FBA, ABF, BFA, any of these work. Questions on any of this here? We ready for the next part? Identifying parallel and perpendicular lines. Two distinct lines in the same plane are either parallel, like L and N, or intersect in a point, like J and N. Though not a point not on a line, there are infinitely many lines. Exactly one of these is parallel to the given line. Exactly one of them is perpendicular. Because if I'm given a line and a point not on the line, there is one line we can draw through that point that will be parallel and one that's going to be perpendicular. Because there's only one of each. We can draw an infinite number of lines that intersect it, but only one of them is going to be parallel and only one of them is going to be perpendicular. Now the parallel postulate, if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. That's our parallel postulate. Our perpendicular postulate, if there's a line and a point not on the line, then there's exactly one line through the point that is perpendicular to the given line. That's just by definition. So, if we look at this first example here, the given line markings show how the roads in a town are related to one another. Name a pair of parallel lines. So for our parallel, we do have those two arrows.
Line BF and line C.
These here tell us that the lines are parallel.
Well, the lines don't have a name, so you have to name the line.
So I would say that DM, line DM is parallel to line EF. Or we could say ray DM and ray EF are parallel.
It is a red, right? So
Mhm.
it's not the-
Yeah. But we're also calling them lines too. Part C, FE. Name a pair of perpendicular lines. So perpendicular lines intersect at what? A right angle, yes? So where's the only right angle marker that we have? BMA. At point M, yes? So one of those lines that goes through point M is BM. Our perpendicular line, our perpendicular marker is an upside down T, upside down looking capital T. Perpendicular to what? Ray, so ray MA would be going this way here. So we could use M as one of our letters, but what would the other one be? D. MD. Questions on this here? Now, the next part is FE and AC. Are they parallel? No. No. They will intersect. That's one way we can say it. Another is FE is parallel to MD. And by definition, given a line and a point not on the line, there's exactly one line that is parallel through it to the given line. And we already have that parallel line. It's MD
So there can only be one set of parallel lines.
through a given point. I mean, I can create infinite number of parallel lines, but not through the same given point. We'll go on and move on to the next one. Because the last part here, can you use the perpendicular postulate to show that AC is not perpendicular to BF? AC, BF. Well, yes, because again, there's only one line through a given point that's perpendicular to the given line. And for BF, the line that's perpendicular to it is AD. And since AC is not MD, it can't be perpendicular to it. Okay. So looking at this here, we want to name a pair of parallel lines. So which two lines are parallel? GM is parallel to Yes. Yeah, because M is down there. So paraperpendicular. So we would still be looking at GK, perpendicular. So the line perpendicular to it is this one here. So what would we name that? Or, if we can say JL or LJ or, where do they intersect? K, so we could say JK or KJ or KL or LK. Because again, any 2 points that go through the line. Because we can use JK or L, we just need 2 of them. Questions on this here? Questions on any of this so far? Is JN perpendicular to, is GN perpendicular to JL? I saw this here. So GN is where? Is it perpendicular to JL? No. They do not. Any other questions on this here? So is GN and JL intersecting at a right angle?
No, they cannot form an
No. So they're not perpendicular.
no, because they don't form.
Or we could say that JL, because again, a line in a given point, G, are perpendicular. There's only one perpendicular line to it. Well, the line perpendicular to JL that goes through point G is GK. So since GN is not GK, they're not perpendicular. Questions on this here so far? Okay. We good with everything we've covered so far? So the next thing we're talking about is this here. Corresponding angles. Now, again, before you start writing this entire passage, because again, this is contained in the book is posted in Google Classroom, so if you want to come back and copy this, you can. But 2 angles are corresponding if they're in the same spot on the lines. So number 2 is where? It's above the line and to the right, yes? Number 6 is where? That's all corresponding means. They're in the same position relative to the 2 lines.
We wrote that in the book.
Because corresponding angles are on the same side of what we call the transversal. That's the line that's cutting the 2 others. And in the same spot on their corresponding lines. So to the right and above. These would be corresponding angles. Questions on this so far? So transversal, so we have the transversal here, yes? 4 and 5 are inside the 2 lines, yes? And they're on opposite sides. So here, 4 and 5 are alternate interior angles. Alternate kind of means opposite, interior, inside. So they're on opposite sides of the transversal, and they're between the 2 lines. So they're alternate interior angles. Questions on this so far? Because we have 2 more. So this one here, 1 and 8 are outside the 2 lines, yes? Alternate exterior angles. Because if they're outside the parallel lines and on opposite sides, they're alternate exterior angles. And the last one is consecutive interior angles. Yeah. Yes.
Can you go back to the last slide?
Said that Suffolk hand.
Yep.
Why do you get all like cowboy southern on
Guys, let's focus in here. Corresponding angles, alternate interior, alternate exterior, and consecutive interior. And we can also have consecutive exterior as well. Consecutive exterior is they're outside the two lines and on the same side of the transversal. It's consecutive interior, they're both inside the two lines and on the same side of the transversal. So the first part we want to do here is we want to name all the corresponding angles. So angle 1, so angle 1 is to the left of the line and above the transversal. So which other angle is above the line and to the left? 5. And we can also have angle 2 and questions on this so far. Because we're going to list all of them. Because angle 3 is below the line and to the left, yes? So the corresponding angle that's below the line and to the left is 7. So to the bottom and front. Questions on corresponding? Alternate interior, there's only going to be 2. Yes. Angles 2 and 7 are both inside the two lines and on opposite sides of the transversal. Then our other one, so we have angle 4 and 5. Questions on this here? Alternate exterior. So we're looking at what?
3 and 6.
1 and 8. And 3 and 6. Because 1 and 8 are both outside and on opposite sides of the transversal. And 3 and 6 are both outside and on opposite sides of the transversal. Yes. 2 and 5 because they're both between the two lines. And they're on the same side of the transversal. Any questions on any of this here? Are you ready for the next part? Anybody still writing? So here, same thing, I just switched the numbers up. Consecutive interior angles. 8 and consecutive interior. So between the lines and on the same side of the transversal, so 8 and 7. And then 3 and 4. Consecutive interior, so we want them on the same side of the transversal and between the lines. Alternate exterior. 2 and 6, yes. And 1 and 5. So on opposite sides of the transversal, the line cutting the two other lines, and outside the two lines. Corresponding. How many are we going to have for corresponding? 4. Corresponding. So we can start with angle 1. And because 1 is above the transversal and to the left, yes? So the other one that's above and to the left is 7. We can look at 2 next. Angle 2 and 4. Because angle 2 is to the left and below. So on the other set, left and below is 4. 3 and 5. 8 and 6, yes. Alternate interior. Yes. 3 and 7, angle 8 and angle 4. Because 8 and 4 are between the two lines and on opposite sides of the transversal. 3 and 7, again, are between the two lines and on opposite sides of the transversal. And that's it. Yep. Any other questions on this here? We ready for the next part? So these last three here, because this is it, classify the pair of numbered angles. So 3, 1, and 5 are on the same spot, yes? So they would be corresponding angles, corresponding. How about 2 and 7?
Alternate exterior.
Yes. And what about 5 and 4? Yes. That's it. Any other questions on any of this here? 3 through 18, and
They say they're all like these.
it's just 3 through 18. 20 is not. No. Three through 18. So 3 through 6, you're naming lines parallel, perpendicular, skew, and a plane parallel containing the point B. Then name pair of parallel lines, name pair of perpendicular lines. Yes, no, corresponding, and naming.